Hello, and welcome to the webinar Stahl's Vision of a Renewable Future with Stahl Ympact as a Cornerstone, brought to you by ILM in association with raw materials pricing website The Sauer Report. I'm Tom Hogarth, Deputy Editor of International Leather Maker, the leading leather industry business information brand. I would like to acknowledge our webinar sponsor Stahl. Two leading leather chemical industry specialists from Stahl will deliver the keynote presentation today. Earlier this year, global chemical specialist Stahl launched Stahl Ympact, a series of leather chemical solutions made with renewable feedstocks. These products originate from biomass feedstock and carbon-captured CO2 with a content of up to 70% and will assist tanneries to reduce their environmental footprint without compromising on quality or performance. Frank Brewer and Dr. Harold Bauer from the company will outline what they mean by biomass feedstocks and how renewable carbon chemistries can improve the environmental performance of finished leather while maintaining all of its much-loved physical and organoleptic properties. Before we start with the presentation, I would like to give a brief introduction to International Leather Maker. ILM serves the global leather supply chain across multiple media platforms, online and through a number of other digital formats, as well as 6 printed magazines. The website, internationalleathermaker.com, is updated several times daily with the latest industry news, views, and information. Please sign up to our free twice-weekly e-newsletter. Please keep an eye out for further upcoming webinars and other digital events which will be announced on our website. We also broadcast a series of industry-specific, free-to-download podcasts which form part of our View from the Top series. You can access all the podcasts by visiting our homepage. So now I am delighted to introduce today's presenters, Dr. Harold Bauer, Global Technical Director, Leather Chemicals, and Frank Brewer, Research Group Leader, Renewable Chemistry at Stahl. Their presentation is titled Stahl's Vision of a Renewable Future with Stahl Ympact as a Cornerstone. Following the presentation, Harold and Frank will join ILM Content Director Martin Ricker for a live Q&A. During the webinar, if there are any questions that you would like Martin to put to the presenters, please leave them with your name and company name, as well as the person you are addressing, and we will do our best to ask them. You can post a question using the GoToWebinar control panel by following the instructions you can see on your screen. Any questions that we haven't covered today can be forwarded to our presenters so they can respond afterwards. So now, sit back and I'll hand over to Frank Brewer and Dr. Harold Bauer for the main presentation.
Thanks for the nice introduction. I also speak for Harold if I state that we're very pleased to be here today virtually to introduce Stahl Ympact to a wider audience. And before Harold will take us in more depth about Stahl Ympact and how it can contribute to leathers with a high renewable content, I will take some minutes to talk about sustainability in general and show how Stahl Ympact has naturally evolved from some of our Stahl core values. So the topic of sustainability has been around for ages, long before I started at Stahl. But initially it was found in the boardroom of companies as corporate sustainability. And luckily this has changed, and sustainability has become a topic which can now be found throughout whole society, and I even dare to state that it has become a license to operate for a lot of companies, especially chemical companies. But what is sustainability? So there are many definitions if we talk about sustainability, but in general they all have the similar meaning, and it talks about living well within the limits of our planet, now but also in the future. And that's a big challenge, and not only because of the growing world population or a growing middle class or our addiction to consumption. No, it's also complex because there is not a real defined path which will keep us within those limits. There are so many different topics, environmental topics, which have an effect on our footprint. You can see on the right side things like climate change, biodiversity loss, deforestation, water pollution, eutrophication, ocean plastics, etc. And so people really have to make choices. So people can have the same need for this authentic, durable materials, but have a really different focus on sustainability. And this is something we have seen in the leather industry. So with alternative materials, etc., where we believe we have a very sustainable materials, but people still choose another product. And this is a real challenge, and also a challenge we as Stahl already recognized a while ago, because I think, what was it, 3 to 4 years ago, I said together with the ESG team, and we said, okay, as a company, we have to come up and define, let's say, a strategy of what we define as uh, sustainable chemistry, or maybe better, responsible chemistry. So what we did is we used the 12 principles of green chemistry as a guideline, and we came up with well, let's say process developments, or how do you say it, guidelines to define what is sustainable chemistry. And these guidelines they can be still found on the website, but these were compressed in what we call responsible chemistry pillars, and these can be seen on this page. So in the core, we're talking about low impact manufacturing chemicals. This is about minimizing exposure of people, employees, customers, as well as the environment to chemicals and emissions. This has something very important, has been around for ages, long before I even joined Stahl, and of course has increased in focus over the years. And this is also something we will continue to do so. Then adjacent to the core is this use of renewable feedstock. This is also the topic of today's presentations. So we see that we need to move away from this limiting or these fossil materials, and try to find renewable feedstocks. And I will talk a little bit more in depth about this later in the presentation. And then last, the outer shell talks about contributing to circularity. And this is in relation to end of life of a material. And this, of course, is yeah, let's say the most out of the box. It's the most, it brings us out of our comfort zone, let me say it this way, as Stahl. But it's very important to move away from a linear economy to a circular economy. So, and I think I took enough time. So I would like to ask Harold. So can you please explain us how what is Stahl Ympact, and how can it contribute to a more sustainable leather process?
Thanks, Frank. You already heard from Frank about responsible chemistry and also the key elements of this chemistry. But if you are looking for the leather process, there are, besides the renewable biomass content or renewable raw materials, there are also some other important parameters which has a big impact on sustainability. This is, for example, the consumption of water. That means what is also necessary today, we have to reduce the consumption of water, especially during the beam house and during the retanning process. That means we have to develop processes with less water, or we have to recycle this water. Another important point is the consumption of chemicals. Also here, we have to make a lot of efforts to reduce overall the consumption of chemicals by more intelligent processes. For example, to avoid a pickling process for chrome-free leather, like for example with Easy White 10. Another key parameter is the consumption of energy. Also here, we have to look in the tanneries how we can reduce the consumption of tanneries by making processes shorter or working at lower temperature. And the other very important point, which is the key point, especially for beam house and also for the overall wet end process, is the wastewater. That means also we have to look to reduce the waste in the water by using products with a far better exhaustion, or find a way to use chemicals in a more efficient way, or to use overall less chemicals than during the leather process. And last but not least, it's also the emission. That means we have to avoid VOCs. That means we have to work with products with very low VOC or with zero VOC for wet end as well as for finishing. And here on the slide, you could see also for beam house, I think Stahl already were working with a lot of green products, for example, the Provera probiotics, or we are working with a lot of enzymes. We already improved the COD in the wastewater. And for example, for the tanning process, where we have also, which is a lot of chemicals, I think with our Easy White 10 process, for example, we can avoid the pickling process. That means we need less salt and less acids. We are also needing less water, and also by a shorter process, we can also save energy, and overall we are using less chemicals. For the retanning, again, it's very important to work here with a lot of low VOC products, if this is for fat liquor, also for some some polymers and retanning agents. And also we have to look for very good exhaustion. That means for a better fixation, that most of the chemicals then are in the leather and not in the wastewater. And for the finishing, and I think you will see this later, we working now more with bio-based polyurethane dispersions with renewable raw materials. How this is now working, you will see on the next slide with our new impact range. That means Stahl introduced a new impact range. This is a commitment to Stahl's corporate responsible chemistry. And with this impact range, I think we defined internal criteria. First of all, the most important criteria is we are adding to our impact range only products with a minimum biomass content of 25%, but most of the products are above 50, 60, or 70. Later you will see this. Additionally, the VOC content have to be less than 1%. I think this is also important, especially for finishing. And also, I think the products have to fulfill the ZDHC or the GADSL. That means they don't have to contain any critical chemicals in the final product. I think this is also important for us. And with this kind of new product range, the new impact range, I think this enables us a transition from more fossil carbon-based products to more renewable feedstocks and reducing the fossil carbon content in the consumption. Frank will now show you and explain you a little bit more about renewable feedstock. Please, Frank.
Thank you, Harold. Yes, of course, no problem. And so when we talk about renewable feedstock, what is it? So we all know renewable energy, which is about decarbonizing our energy sector, moving away from fossil fuels. Well, this is, of course, is more problematic for the material industry because we cannot decarbonize our materials. We need the carbon to have certain kind of properties. So what we need to do is we need to find alternative carbon sources. So no longer fossil-based materials, but we need to find carbon which is already available here on Earth. So and for a lot of people, biomass is a well-known renewable feedstock, but there are more. For example, we can also use CO2 by capturing CO2 and convert it into chemicals, or we can take, for example, recycled materials or materials which we can use as a feedstock in our existing products. Now for the leather industry, I have to be honest, that biomass, this is of course the most known topic of the most known renewable feedstock, and I think it will also be the most used because of the fact that the leather itself is bio-based. Well, important for biomass is to understand that there are different generations. First generation these are, let's say, crops mainly from arable land, which could compete with food. Second generation talks about also crops grown on arable land, but then with not in competition with food. This can be straw or waste streams or woody lands or even non-food crops. And the third generation, then we talk about materials which has been grown in marine life, so in marine environments, so algae, for example. And of course, we prefer to use materials which we can make from the third generation biomass feedstock, but we have to be honest that if you talk about best available technology, a lot of materials nowadays are still first generation. But of course, when this changes, when we see product development, then Stahl will change as well and focus more on this second generation feedstocks as well. And so this nice picture, so we use this biomass converted via chemical companies where we have close contact with into raw materials which we can use, and we convert those into products, biomass products, but also finishing products and wet end products. And I think Harold, can you explain a little bit why would we like to use these renewable feedstock, by the way?
Thank you, Frank. You could see here on this slide, I think if you are looking for the biomass content of the different process steps for leather, and if you are starting at the rawhide, you could see on the blue bar, the rawhide has 100% biomass content. That means this is a purely renewable raw material, which we are using then to prepare later than the final leather. If you are switching now to the next process, this is for the beam house. If you are starting with soaking, liming, deliming, and bating and pickling, if you are using this kind of different chemicals for this process steps, normally I think this kind of chemicals are not incorporated in the leather. They are only removing the hairs, they are removing the fat, they are opening up the collagen structure and everything. That means the impact of chemicals used in beam house, you will have here a major impact on the wastewater, but not on the biomass content of the leather. If you are then starting with the tanning process, and okay, with the tanning process, you can use chrome tanning or you can use chrome-free tanning process. This can be done with easy white tanned or glutaraldehyde. And if you are starting to introduce here easy white tan, which is not based on a renewable base, then you will add additionally fossil-based content, which is then marked in with the orange part. That means you are getting at the end of the tanning then 95% of biomass content of the leather and 5% is fossil-based. That means if you, for example, if you are adding here some vegetable tanning agent instead of easy white tan, then you will see this is 100% bio-based, and then at the end you have of a vegetable-based tanning agent, you have then 100%. And this varies then depending on how you are tanning then your leather. If you are moving then for the retanning, and for the retanning, I think this is already visible. You could see here then at the end of the retanning, if you get the final crust, you will have then roughly 17% of fossil-based carbon then in the crust leather. This is coming then from polymers. This is coming from retanning agent based on synthanes, and also dyestuffs and some auxiliaries. That means the retanning has the biggest impact then later on the final biomass content of the final leather. If you are looking then for the finishing, and also in the finishing again you will increase then the fossil-based content in the leather, and at the end, if you are working then with a conventional finishing system, that means which contains no biomass content, you will end up then for a finished leather of roughly 24% is fossil carbon based and 27% is bio-based carbon. And how we can increase then at the end the bio-based carbon content for the final leather, and for this we developed then our new impact range. On this slide you see first the retanning, that means the wet end impact range, and we developed here, this is a starting point, this kind of impact range. That means of 15 products with a very high biomass content, and we have also for the wet end the same criteria what I mentioned at the beginning. The minimum is here 25% of biomass content, and also the VOC is less than 1%. And we developed here also products for the neutralization. We developed retanning agents, we developed fillers, we developed fat liquors, and we developed resins and also polymers. And I think it's very important that you have here a very high biomass content. And the base of this impact products are the feedstock is here sugar, the feedstock is starch, lignin, lecithin, vegetable, protein. I think these are natural raw materials which are in big quantities available. We also measured here the biomass content with the ASTM D6866 method. I think this is important that you have here also a standard and not only saying I have a green product, I have a lot of green content. This is measurable. And if you are preparing here a re-tanning recipe based on wet white leather, that means you could, and you could see this in the lower part, you could see here the conventional retanning, and you could see here retanning with impact. You will get then roughly a reduction of the fossil-based carbon then for the retanning of 40% for special recipes. I think this is very important, and especially with this kind of impact wet end range, we are able to further reduce then the fossil-based content then of the crust level. And if you are starting then here from 17%, and this is going down then of 40%, you will end up then for this optimized recipe, maybe at around 10% of fossil-based carbon content then in the final crust level. What we developed for wet, and we also developed an impact range for finishing. And if we are looking here for finishing also we have the same criteria like for wet, and that means minimum biomass content of 25%, low VOC. This you could see also in the table. It's below 1%, and it's also compliant regarding ZAHC MRSL. I think here also we have here a complete polymer group starting from adhesion coat, then it's going over base coats, and also we have here different top coats, one polymer top coat, one silica dulled top coat, and one gloss coat. And with this kind of impact polyurethane dispersions, you can cover up mainly 80 or 70-80% of the finishing chemicals. I think this is very important, and if you are looking here, for example, for the different steps for finishing, for the base coat, we could reduce also the fossil-based carbon content of roughly 30 or minus 33%. If you are going then to the color coat, we get less than 40%, and if you are going to the top coat, then we can reduce it by 27%. Overall, if you are put this together, then we can reduce fossil-based carbon from the finished leather of more than 30%, depending also on the add-on what you are using of finishing chemicals in the recipe. But this is a complete finishing range. We are still missing products, for example, like crosslinkers, like some auxiliaries, pigments, but we are also working on that we are also getting then here other products for finishing with a biomass content. What we overall reach then with the impact range, and this you could see on this slide, and this is a conclusion of the impact range on the leather process, starting from beam house to finishing. You could see if you are starting on the rawhide with 100% of biomass content, at the end we will end up at 24% of fossil content and 26% of biomass content for a finished leather. But with the Stahl Ympact, we can further optimize that at the end we are coming closer and closer then to the 100%, and we will reach then with the optimized Stahl Ympact recipe then only a fossil-based content of 5%. And this is done then over for the tanning, this is done for the retanning, this is and also for the finishing. I think this is a very good starting point to make the leather process more sustainable with our Stahl Ympact range. Now the question is, if we are increasing more and more the biomass content in our chemicals, does this have also an impact on the biodegradation? This is a question then to Frank, and can you give us here an answer? Is there a correlation between biomass content and biodegradation?
Thank you, Harold. I think this is a very good question, and I think it's a very important question to answer as well. I think we've seen that what you're saying, the same question a lot of people have, a lot of customers have when we have a bio-based material, it's then also biodegradable. And I have to be very straightforward. There is no direct correlation between bio-based and biodegradation. Because both are properties, have material properties, but bio-based tells something about the origin of the material. We have seen that it is derived from biomass. This can be plant, animal, or marine, or forestry materials. And biodegradation is also a property, but it tells something about the end of life of the material, that it's capable of being degraded by biological activity. So it's possible that we have bio-based materials which are non-biodegradable, and we have fossil-based material which are biodegradable. It really has something to do with the structure instead of the source of the carbon. And I think that's really important to tell, because it really has been a topic, biodegradation. We see, I think, in social media, but also in publications, a lot about biodegradation. And I would like to take a minute to talk a little bit about biodegradation, because also it's part of the responsible chemistry strategy. We talk about end of life, contributing to circularity. Well, biodegradation is often seen as let's say the holy grail, as a panacea. But we have to be careful, because biodegradation on itself only states that a material can be broken down by bacteria, fungi, or other via other biological means, but it doesn't say anything about conditions or the environment, or which kind of product will you end up with. So biodegradation is not the same as composting, because composting is biodegradation in a controlled environment and conditions, and the end product has a beneficial use as fertilizer and improving soil health. And I think that's really something people need to understand, is that it's very difficult to make a statement on composting. So then fragmentation and disintegration sometimes also mentioned. These are not forms of biodegradation, although they can help sometimes the biodegradation because of smaller pieces. But be careful, partially biodegraded materials can also have a negative effect. Can be pollutants in marine or soil environments. So again, biodegradation is not a panacea. I do want to, so if I want to conclude something on this contribution to circularity. So although biodegradation / composting might seem a suitable end-of-life strategy for leathers, we of course, as we're very good in making very stable leathers which can last for a long time, and I think that's the beauty of the leather product. So really, to make something which is really stable over a long period of time, but then can break down when it's no longer wanted, that's really a challenge for the future, and also definitely a challenge for Stahl. So thanks for the question. So Harold, I want you to take a last look at the Stahl Ympact range, and maybe give a nice overview of how our vision is for now and in the future.
Thanks, Frank. I think during this presentation we presented you the Stahl vision to a renewable future with our new Impact range as a cornerstone of this vision. And this vision, you could see this here on the slide, is divided in 3 different phases. The first phase, I think we started this already years ago, was the cleaning up of existing products. That means here we have to look that all the products, the existing products which are fossil based, are also fulfilling the ZAHC MRSL requirements. I think we started to reduce the bisphenol contents and of other toxic chemicals. I think this was already mentioned in the part of Frank, to minimize the exposure here of chemicals. In the phase 2, we started here then already with the new Impact range. That means this is a clean and renewable product range with a high biomass content. And I think this Impact range is not started not only for finishing, this is in the meantime extended also to wet end. And we already started in beam house, I think with Promira, which is also 100% bio-based. I think this is for us a journey in the future. And with this phase 2, this is an ongoing process where we want to extend our product range and switch more and more from the fossil-based products then to bio-based products for the whole product range then for leather making. And in the phase 3, and this was already mentioned by Frank, I think we are starting to expand and also the Stahl Ympact range, but nevertheless, we will also looking for the end of life. That means for the biodegradation and the composting of products. That means for the circularity. This is the last step. And at the end, this is a journey regarding to a more sustainable production. And one important part of the journey is at the moment Stahl Ympact, and we will further go on this journey. Our target is to maximize the biomass content in our leather product range. The target is also to get at the end also then biodegradation and composting, but which is far more complex, what you heard already from the part of Frank. And it's for us also important then, especially with the high biomass content, I think we are creating also a more and more attractive substrate leather, finished leather. It means leather is, you heard this, the rawhide is already 100% biomass content. if you have at the end then a final finished article also with a biomass content which is close to 100%, I think this is also very attractive then for a consumer to have really here a sustainable natural article which is based on leather. And therefore we are very optimistic, especially with this kind of impact range, to get far more sustainable products and to get at the end a far more sustainable leather article. Thank you very much for your attention.
Let's just wait for Peter and Frank to join us. Hi, Harold, Frank. Good morning or good afternoon to everybody listening. I just wanted to mention that you can post a question to any of the presenters using the control panel on your screen. Any questions that we haven't covered today will be forwarded to Harold and Frank so that they can respond to you directly. Please make sure that you specify the name of the presenter you want to ask the question to. Frank, if I could ask you a question first. As we move towards using more chemicals using carbon from renewable feedstocks, do you envisage any negative environmental consequences, such as more competition for land use, for pressure caused by using these resources against growing food for people, for animals, or biodiversity loss? I mean, how can this be managed?
So, good morning, Martin. Thank you for the question. Very pleased to be here, by the way. Yeah, it's a very good question. I think it's also one of the most debated questions within this renewable carbon world, because how to say it? Everything we do, of course, everything we use to a certain extent requires resources, and that's not different for bio-based materials. So, and I think everybody can understand, of course, that if you need to grow something, that it will have a different type of, it requires different type of resources than something you can mine, for example. So in general, people would say, okay, that's easy. So hey, you need to grow. So indeed, it competes with food. But in reality, it's more complex, and I think it's also that's also the reason why, for example, renewable carbon, it doesn't only talk about biomass, but also the other topics. I think it will also be very in the future will not only be bio-based, but it will also be based on recycled materials and captured carbon. To be honest, but if you really look to the biomass alone, I think then the bioeconomy is really, of course, looking at how we can look at the individual materials and define which is the most efficient. How can we make more efficient processes? So I think it's a continuous process. Also, what I think Harold already explained is that this is not a start and it's not an end point. It's a beginning. And I think what for us as Stahl is important is that we keep our supply chains transparent and we keep also evaluating, so that we learn, okay, what is available on the market, and are there better choices, to be honest. But that is what we need to do. So yes, there is to a certain extent some competition with food, but this is something we have to learn, and I expect that within this bioeconomy we will find solutions to this issue. Yes.
Thanks, Frank. Harold, in order to reduce sort of waste, sort of solid, liquid, and airborne at the tannery, does the Stahl Ympact range focus on supplying chemicals with like fewer bulk inert sort of filling and bulking chemicals to not only reduce tannery waste at the end of the process, but also to sort of reduce transport costs and lower the overall footprint?
Good morning, Martin, first of all. It's a very interesting question, because we as Stahl, I think, and especially with the new impact range, we really try to minimize the environmental impact. And this can be done, first of all, by producing with low energy or with green energy, using more of biomass products. And also we are trying then to produce the products, if this is possible, then close to the market. That means also locally, to avoid an expensive transportation and everything. This is something which we already trying. That means close with less impact than on the environment. I think this is That's a good question regarding the other part of your question regarding inert bulking or filling chemicals. We are using normally chemicals which has a function then for the leather process, and not which is only filling the products that you have 100% of active content or what else. I think this is at the moment not the case then for our impact range, and also not the case for our other products at Stahl.
Mm-hmm. Okay, I've got another question for you, Harold, which is from Stefano Peratello from Lamberti. He says, considering the thickness of the finishing layer is like tens of microns thick, how can this have such a big impact on the weight balance of bio-based carbon?
No, the add-on has a big impact. For example, if you have finishing products with 50% of biomass content, and you can add in, for example, if you are avoiding finishing and you only have aniline leather, okay, then you have no impact in finishing then on the biomass content of leather. If you are making a semi-finishing article, then okay, you are adding less. And if you are adding less, then okay, you have at the end less fossil-based material than on the leather. I think this is something which we have to see. That means the impact without finishing, that means is then zero fossil content regarding finishing. And if you only have a slight add-on, then it's less. I hope this will answer your question.
Yeah. Frank, back to you. A question from Yuji Ma. Can you tell us a bit more about the lignin-based retanning products and resin products?
So after a good question. I think so Harald, so I think this is maybe a more appropriate question for you in terms of retanning. For the finishing, I will take the floor. So at the moment, we don't have any finishing product which contains lignin. Of course, this is what if you look at, let's say, what kind of waste streams could we convert into products, this might be an option. But you have to understand, of course, also for finishing, it's important that we have a product which can also bring quality. So and lignin, as being a quite complex molecule, complex structure, it's very difficult to it's more difficult to really use it as a raw material for finishing. So yes, of course, this might change. There are chemical developments in that field, so maybe we'll come with something in the future. But at the moment, for finishing, we don't use it. So but for retanning, Harold, maybe you can comment on this.
That means lignin is a very interesting one, because it's what you already mentioned, Frank. It's very complex, but it contains group which are similar than to the traditional phenol group in the phenol condensation products. And this will help then to simulate it then with a bio-based product, and a molecule like the synthans, which we are using normally for the retanning. That means we are trying to copy or to look in the nature what is available in the nature and what is similar to existing technology which are working very successful to make leather. Therefore, lignin is one thing, because it's in huge quantities available. This is also important if we want to switch then for a renewable chemistry. It's the availability, and that we are not in what Martin was asking Frank, that we are not in competition with the food industry, and that we are, I think this is also the key then for a really sustainable then at the end production of leather, if you are using then chemicals which are side products from another production and which are really renewable.
Mm-hmm. Frank, I've got another, Harold, I've got another question for you. This is from Marcelo Salcido. Is the impact range, are the impact range products not applicable for chrome products, and why? If so, are there plans to make them applicable for chrome products, especially regarding finishing products? Does that make sense?
You can use the impact range for chrome free. You can use this for chrome leather. That means the impact is that you have at the end more biomass content in the leather. That means if you have a chrome leather, okay, chrome is normally not based on carbon. That means it's a metal. That means if you are tanning your hide with chrome, then okay, you still have 100% biomass content if you are measuring then the carbon content. I think this is something all the inorganic substances are not here included in the calculation. You can also include it, and you can discuss if chrome is really sustainable or not. But you can use also the impact range for chrome leather, for wet end, and as well as for finishing.
Correct.
Okay, I don't know who's going to take this one. This is from Peter Thomas from Zimmer & Schwartz. If you are considering the carbon content via ASTM 6866, then you are considering the renewable carbon content in the complete carbon content, then it can give some discussions if you call it biomass content. I hope this is making sense. But my question is, if you are using CO2 carbon capture methods, is it sometimes interesting to capture the CO2 where it is produced in large amounts? But if this industry is still using fossil fuels, then in ASTM method, you will still get more negative results as you captured the fossil-based CO2. Any idea how to solve this problem?
So it's a very good question. And so that is, of course, so if you really want to measure, and it was already mentioned, so you use this ASTM method. In principle, what it only states you measure fossil versus modern carbon, so material which is in there because of the plants. So indeed, if you capture carbon from a flue gas or something else, which in principle is indeed, these are often not captured really from the sky, but really of high CO2 containing or Cu containing processes, like electricity, how to say it, a generation or this kind of stuff. And indeed, if you would measure those, these will not be measured as renewable feedstock or as renewable feedstock, but not measured as and will not pop up in the ASTM method. So that's complex. So if you would like to maximize your bio-based content of your leather with that kind of materials, it will not be visible in that perspective. On the other hand, you also mentioned this that we cannot look only at biomass, because probably therefore we also need to look at these other alternative carbon sources. And in the end, of course, if we would calculate it using LCA or something, you will see an advantage over materials which don't use this captured carbon. So this is a more complex situation indeed, and that's also the reason why most of our products indeed are focused on really on biomass content, because this is measurable. Also in the final article, you can just measure your leathers, and indeed, if you use a product which contains captured carbon, then it's more of an added advantage. So something like that. Yeah. I hope that answers the question.
Thank you, Frank. I'm glad you understood the question, because I wasn't sure. Harold, when we talk about low VOC content in the impact range, Stahl Ympact range, you mentioned this would be like less than 1%. Is this to improve the environmental conditions during manufacture within the tannery, or is it sort of to reduce the VOC content in the final sort of leather and leather product? What's the benefit?
The benefit is for both. That means it's a must to reduce the emission, especially of solvents and everything. I think this is also sustainable. And here it's also important for us that we have a safe handling, that it contains less toxic products, if these are solvents or what else, which has an impact then on the workers. I think this is also our responsibility. And this is not only for green projects or like the impact range. This is for all our product range, also for the fossil base, to reduce here the VOC content. This is a requirement from our customers. I think this is especially then from the automotive industry, further to reduce VOC content. But I think at the end it's a request from everybody to avoid this kind of VOCs, and we are trying to do this with all new developments, then to have an extremely low content of VOC, and the product is still working. I think this is not so easy to say, okay, I want 0 VOC or less than 1%. This is for the technology which we have to handle at the moment, and for the leather finishing as well as in wet end, extremely difficult. But okay, we need also ambitious targets. That means to make our products, our article, and the world more sustainable. And for this, I think this was also an internal decision of Stahl then to try to do this also then with the new impact range.
Mm-hmm. And Frank, you mentioned during the presentation that there are sort of 3 generations of renewable feedstocks. Using today's sort of best available technology, which of these sources do you think is the most interesting, which will develop in the next generation of leather chemicals? And do you think they have the same performances as existing chemicals? And you know, ultimately are commercially cost effective?
Okay, thank you. I think I will first answer the question on how to say it, if the same quality or the same property. So of course, people have to understand when you convert biomass, it's not only an extraction process, but often it's also a chemical process where you really convert it into a specific chemical. So it is even possible to really have a drop in to have a similar performance or a similar materials where you don't even need to change anything. It's really just replacement of something for something else. So a fossil for bio-based. And that also really depends on generation. It is possible to use first generation feedstock as a sugar, for example, and then make a chemical, and then use, when the technology becomes available, use second generation feedstock, which is then a waste stream of cellulosic material, and then convert that into a chemical. So if you talk about best available technology, we see still a lot of focus on first generation, but if you now follow the debate, indeed there is still increased interest in the second generation process, where we really focus on waste streams. So we really need to find where in the market are there still waste streams which we can use in biomass and convert those into raw materials we can use. And that is, I think, a little bit your answer. So our preference is now, I think at the moment, waste streams as secondary biomass streams, but we also still not have to forget the first generation. So I always see it like this: you need to start somewhere, and you need to what I said, it's a process, and I think we need to become confident with using these materials, with bio-based materials, and therefore we really need to start with first generation in some cases. But when it becomes available, we need to switch to maybe higher generations if possible. Yeah.
Mm-hmm. Okay, well, I've got 2 more questions, and then I think we'll wrap up the thing. The next one is for you, Frank. This is from Raul Sartori. What about bio-based acrylic resins for finishing and retanning? Are they available yet?
So it's a good question, and so I think, as Harald already explained, this is just the first setup. So we made a first portfolio, and we hope that we will extend this portfolio continuously in the next years. And of course, acrylics are part of that portfolio, and also something we are looking into. But you had again, this is a question about availability. What is available? What if you really want to have a certain, if you want to have a, how do you say it, substantial bio-based content at an affordable price, or at least a price which people want to pay, then sometimes materials are not yet at that stage. So that is something, I think, related to acrylics, which is often seen as a little bit cheap end of the market. And then biomass maybe is a little bit too expensive for the moment, but I expect this will come. Yeah.
And Harald, if we just conclude with you, there's another question from Yuji Ma. Renewable feedstocks does not automatically mean sustainable. Do you have quantitative measurements on sustainability of the products, such as an LCA study?
Yes, for that means we are normally, before we are starting with some renewable material, we are discussing that and we are investigating that. Okay, and therefore you mentioned this, the life cycle analysis. I think this is already done or is done then for key raw materials, that we are not ending up then in a totally wrong direction. I think this is the key today, to make the right selection. And this is not only one solution, there are different solutions. And also maybe to make some additional remark regarding the acrylics. That means if you're looking what is possible for acrylics, if you're looking for ethyl acrylate, you could see there exists already alcohol based on biomass content. I think you will get some acrylics, but only from this monomer. And at the end, this is the challenge for the whole chemical industry, to look here for different raw materials, for different sources, then also for this mass material, like the acrylic monomers. There exists something, but at the end, it's maybe the key then also for the industries to look then that they can start very early. That means normally acrylic monomers were prepared from propane. That means if we found something, then we can use also biomass content to prepare propane, then okay, you can increase it. The same is then at the end for silicones. That means how you can make biomass content for silicones. This is then only maybe possible if you are using then some hydrogen, which is created electrolytically with green energy. I think these are the questions where we have to look, and this is an ongoing process, not only for us as Stahl, this is for the whole chemical industry. We have to look. Therefore, it's difficult, okay, to say, okay, what is biomass content, how we can measure it. We decided for the starting point this ASTM method, but there will be then other green basic or raw materials which can then be used and also to prepare then some acrylic dispersions. We can maybe then also use some isocyanates with some green content to increase here more and more the green content then for all our products. But this is not only Stahl, this is the whole chemical industry, which is the key.
Yeah, definitely watch this space. This is definitely an area that's going to develop and evolve. I think we'll wrap up the Q&A there. If anybody attending or watching this on the video wanted to get more information, what should they do afterwards, Harold?
Or Frank, you can maybe.
No problem. So but I understood that, so people are able to book I think 30 minutes or longer if desired with us. I think there will be a link soon on the LinkedIn of Stahl, or maybe via a newsletter we send out to the people who are attending, so where people can book 30 minutes if they want to discuss a little bit more in depth about what we have discussed today.
And if anybody listening wants to, or watching, wants to contact Harold or Frank and don't have their contact details, feel free to email me and I will definitely forward them on. Okay, thank you very much, Harold and Frank, for your time today. I really appreciate it. And I think if you want to turn off your cameras and mics, I will just wrap up the webinar for today. Thanks very much for your time.
Thank you, Martin.
Thank you.
So this concludes the webinar for today. A huge thank you to Dr. Harold Bauer and Frank Brouwer for sharing their thoughts and ideas on how new technologies from renewable carbon feedstocks can really help tanners make more sustainable leathers. I'd also would like to thank Stahl for their sponsorship, and I think we've learned a lot about the renewable carbon feedstocks today. A link to the recording will be sent out to everyone who's registered for today's webinar. We will also be posting the full webinar online in the weeks to come in case you wanted to view it again. And this will be available from our website, which you can see on the screen in front of you, and we'll also put it on YouTube. And finally, you'll now be asked a short survey about today's webinar, which will give us some valuable feedback to ensure that we're offering content that continues to be of interest to you. As mentioned at the beginning, ILM and the SAO report will be hosting more free to attend webinars, as well as new podcasts over the coming weeks and months. So please keep an eye out for future topics on our website. And our contacts are obviously, the website is on the screen in front of you. And just a quick thank you to my colleagues Tom and Alpa for helping me with this webinar today. Thank you for listening, and goodbye.